Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's illustrate the limit of a polynomial function using a table of values. We can determine the limit of a function, or here specifically polynomial function, using a table of values, because we could see the possible value that our function will approach to as we also try to use a certain value for our x to a certain constant c. Let's try this given function here. Let's have f of x equal to 2x minus 1. And let's try to determine what is the limit of this function as our x will approach to a certain c, let's say 2. We can determine the limit of this polynomial function as x approaches 2 using a table of value. But we are going to show or illustrate both sides. Let's try the values to the left of 2. Let's say if x is equal to, let's use this table here. If x is, let's say, 0, the value of f of x, when substituted, when the value of x is 0, substituted to our given function, 2 times 0 is 0, we have here negative 1. If we are going to use other value approaching to 2, let's say 1, from the left, 0, 1 until 2, the value of f of x will be 2 times 1, which is 2, minus 1, 1. Now, of course, we're also going to consider other values aside from integers. So let's try to use here 1.5. If you're going to use here 1.5, 2 times 1.5 is 3, minus 1, you will have here 2. What if we are going to use here 1.9? Because our goal here is to show the values of our, or the possible values of our f of x as we are going to approach to 2. But we will not be touching 2. We are just going to use the values closer to 2. In this case, 2 times 1.9 is equal to 3.8 plus minus 1, you will have here 2.8. Let us try also 1.99. So it gets closer to 2. If we have that, 1.99 times 2 is 3.98, minus 1, you have 2.98. Let's have one more. If we have 1.9999 closer to 2, we are going to have this result. So 1.999 times 2 will have 3.9998 minus 1, you will have 2.9998. As you can see, as x approaches to 2 from the left, we could see a trend on our f of x as it also gets closer to a certain value, which is 3. Because 2.9998 is closer to 3, and if we're going to apply or illustrate other values, it will still get closer to 3. This would mean that the limit of this function as x approaches to 2 from the left is 3. That's the limit. Now, before we say that this is the limit of the function, we also need to show the values from the right side. Here's the catch. We need to make sure that the value as of f of x as x approaches to 2 from the left and from the right will have the same value before we could say that that is the limit of our function as x approaches to 2. So what are the values from the right of 2? Let's try to use here 4. If we have 4, 2 times 4 is 8, minus 1, that's 7. Let's use another integer, let's say 3. 2 times 3 is 6, minus 1, I have here 5. Take note that we are using the values of x for our given function here. Of course, we're getting closer to 2, but we will not be touching 2. So let's try to use 2.5. 2.5 times 2 is 5 minus 1. You have here 4. Let's add other values closer to 2. So let's say 2.1. If you have 2.1 times 2, that's 4.2 minus 1. So that's 3.2. Let's have closer, or a value closer than that. Let's have 2.01. So it's getting closer to 2, but we will not be touching 2. So if we have that, 2.01 times 2, that's 4.02, minus 1, that's 3.02. Let's have one more. If we have 2.0001, so it gets closer to 2. If we have that, 2.0001 times 2, that's 4.0002, minus 1, you have 3.0002. As you can see, as we have the values of x approaching to 2 from the right, because these are the values from the right of 2, we have here a trend for f of x also getting closer to 3. With this here and 3 here earlier as well, since the value from the left, or the limit of the function from the left of 2 is equal to the limit of the function from the left from the right of 2, which are both 3, we could say that the limit of the function as x approaches 2 is equal to the same value of 3. This is how we illustrate or show the limit of a function using table of values. We will have more examples later. So what are you waiting for? Subscribe now!